Hello, so I've taken these two Cartesian equations and I've found out that the original curve was y equals minus a half x squared plus x plus 1, okay, and now what I'm asked is to find the set of values that x can take, and then I want to sketch that curve. So it's a quadratic curve and it's a negative quadratic curve, so I know it's going to look sort of an upside down quadratic effectively. So it's an upside down parabola. Okay, but let's have a look. We'll get there first of all. Let's do the first part first. So find the set of values that x can take. Okay, well look, the key is here to look at my original parametric equations. So I've got x is equal to 2 sine t, and I'm going to show you a really neat, well I think quite neat trick, to find out what the values of which x can take. So I know that x is equal to 2 sine t, okay, like that, okay? So if I just look at this side of the equality, so I just look at the 2 sine t side and find out what values that can take, then fairly obviously x is also going to be able to take those same values. Are you happy with that? So it's worth just bearing in mind then, what are the original values that t can take? Well, t can go from, I'm going to do it in terms of degrees because you're probably more familiar with degrees, negative 90 and 90. So if I just draw the sine graph between negative 90 and 90, okay, I'm going to end up with something that looks like this, okay, so that's negative 90 and that's positive 90. So basically the idea is that I go through all the values that it can take on the y-axis effectively. So this is like sine t, okay, basically I go from negative 1 to 1, so I basically do all the values on this axis that I possibly have to. So I know it's going to go between negative 1 and 1. So I can fill that in, okay, so I know that sine t goes between negative 1 and 1. So I write that as an inequality, okay? Then the idea is then I just build it from there. So I start with an equality that I know, okay? I know both sides, I know the bounds. I know this side is negative 1, and I know this side is 1. I know that sine t goes between negative 1 and 1. Okay, and then I build it up from there. Because if you look, I don't want just sine t, I want 2 sine t. So all I do then is I just multiply everything by 2. So I want 2 sine t. Okay, well sine t goes between negative 1 and 1, so if I just multiply it by 2, then this must become negative 2, and this must become 2, okay? And I know that x is equal to 2 sine t, so I just replace that with x. So I know that x must go between negative 2 and 2. Those are the set of values that x can take. So alright then, let's try and plot this graph. Let's actually try and sketch this graph. So like I say, it's a negative quadratic graph, so I know it's going to be an upside down parabola. So first things first, I am going to draw my axes out. Okay, of course you should use a ruler and pencil in the exam, but it's difficult to do on here. So this is my x-axis, this is my y-axis. Okay, so negative quadratic graph. Right, do I know enough to draw the graph then? Well, I know that it crosses the y-axis at 1. Okay, I know it crosses the y-axis at 1. Do I know the coordinates of the endpoints? So the endpoints, remember, I'm only plotting it between negative 2 and 2, so I suppose I should plot that on. Okay, so negative 2 and 2. I know that it crosses the y-axis, just established it crosses the y-axis up here at 1. Okay, so 1, 0, effectively. Actually, let's draw that a little bit better. Okay, let's draw that sort of down here, I guess, sort of in terms of, in scale kind of thing. Okay, so it's going to cross that 1. Do I know the y coordinates of these endpoints? So in other words, when I kind of sketch the graph in sort of thing, do I know do I know the sort of endpoints? So I do know sort of the endpoint here and an endpoint down here, for example. Let's draw that in again. So say it goes something like that. Oops. So something like that, for example, I don't know. Do I know the coordinates here, and do I know the coordinates over here, for example? So do I know the coordinates at 2? Sorry, that's so badly drawn. But yeah, basically, do I know the coordinates down here, and do I know the y coordinate down here? So do I know this one, or do I know this one over here? Well, I can work it out just by sticking my x value into this original function. So let's stick, first of all, negative 2 in. So let's find the coordinates of this endpoint down here. So the endpoint down here is going to be, so when x is negative 2, y is going to be negative a half times by negative 2 squared. That's times by 4, isn't it? Because 2 squared is 4, and then it's negative times negative, so it's going to end up positive. Plus, well, it's going to become minus 2, isn't it? Minus 2 plus 1. So what's negative a half times 4? That's going to be, well, half of 4 is 2, so it's going to become negative 2 plus 1. So negative 2 is negative 4, plus 1 is negative 3. So the coordinates down here are going to be negative 3. Okay, then what about when x equals positive 2, so the other endpoint, the coordinates of the endpoint over here? Well, just the same thing again, so it's going to become y equals negative a half times 4 again, okay? But then I've got a plus 2 Okay, and then plus 1. Okay, so it's going to become half of 4 is 2, so it's going to become negative 2 plus 2, they're going to cancel, so it's going to end up with 1. So this coordinate over here is actually just going to become 1. Okay. So I know actually that this endpoint over here is going to be at the same height as where it crosses the y-axis. So let's draw this a little bit better then. So it's a negative x squared graph, so I know it's going to go up like that. So let's draw it in. So I'm going to go like that, okay, and then I know that it kind of loops back down there. So if I just move the scale across a little bit, and actually that's a really good tip in the exam, okay, so this is actually 2. Draw your graph in first, draw the curve in first, then put your numbers on, rather than trying to fit the curve to the numbers. Okay, it's far easier to actually draw the shape of the curve. You know roughly where everything's going to happen, and then you can basically just put your numbers on. Okay, so I know this is negative 3 down here, so let's put the coordinates on. So negative 2, negative 3, and this one is 2, 1. Okay, just so the examiner knows that I know what I'm doing. This crosses at 1, so I'm just going to change this to 1. Can I put anything else on there? Can I put any other information on there? Well, I could put this I could find what this root was down here, for example, but I'm not going to bother with that. That's a little bit too work. You just basically have to solve this equation. But I do know actually another bit of information. I've already found the other bit of information. What is the turning point of that graph? Well, that turning point is just a stationary point. And if you look back at part 1, we found the stationary point was, I think it was 1, 1.5. Okay, you can go back and check. I haven't got it here. But yeah, you can go back and check, and it should be 1, 1.5. I think that's right. Okay, so basically the idea is, okay, when you're doing it, it's good exam technique. If it's part of the same question, like, there's probably a reason why they're getting us to do it, okay? So they got us to find the stationary points in part 1. Well, why? You know, it wasn't just because they're being horrible, it was because we're going to use it again in some other part of the question, okay? So basically, this is what the graph is going to look like if I just get rid of all the stuff around it. This is what the graph is going to look like, okay? I've put all of my points on, basically. I've sort of marked all my points, critical points. I've actually looked at the mark scheme. You only need to put one of these things on. So either put the end point on, or you put the stationary point on, or you put the intersection with the axis. But as long as you kind of got the rough shape right, and you found the right range of values. Remember how we found the range of values? We just simply started off with something we knew. We knew the range for sine t, and then we could build on it from there to find the range of 2 sine t, which just happened to be x, okay? So hopefully that makes a little bit of sense. It's not that difficult if you actually kind of break it down and treat it part by part.